Hello, honors algebra students. Mr. Lawrence here, almost sounding like myself, with your review for chapter 10. You've got your test on Friday. We're going to spend Wednesday and Thursday reviewing. Many of you need a very good grade on this, and some of you have a good grade and you don't want to lose it. So please watch this as many times as you need. I'm going to go through the major concepts. I'm not going to go through like 800 examples, but major concepts. And you can come in and get some help. You can do extra practice, the extra problems in your book, whatever it takes. All right, the first one is we're going to solve and graph this quadratic equation by factoring. Now hold on a second before I actually do anything. I'm going to go here. Okay, I put together a little notes page here. You should already have these from previous videos, but some of you seem kind of set on just doing everything all at once, and then you forget most of the things you're doing. Look, be very systematic, and I know Miss Eubank has been very systematic in her approach, and I was talking to a student's father. Well, I actually heard his message on the phone, and he was talking about how he created a very systematic way for his son to do these problems, and I thought, what a great idea. Although we've been doing that, but some of you choose to not do it. But I'm sure I'm glad to have the support of a parent who's willing to sit down and do that with a kid. I mean, you know, not all parents can do that because not everybody has a math background, but the student is very lucky that their father was able to do that for them. Anyway, so to graph quadratic, first we're going to use the discriminant to find the number of solutions. Okay, that's almost always the case. The only exception to that would be is if I was graphing it. I might just go ahead and graph and I'll be able to see my number. So, excuse me, if I was factoring it, I would go ahead and just factor, and then I can tell how many solutions I'm going to have. But usually I'm going to use the discriminant right off the bat. Again, the only exception might be to factor. Now, if I have a factoring problem, can I still use the discriminant? Absolutely. You go ahead and do that. Just got to be conscious of your time. All right, number two, after I've found the discriminant, I'm going to know how many solutions are. Then I'm going to go looking for the vertex. And I'm going to use x equals negative b over 2a. I probably won't average the roots to get my x coordinate of the vertex. I can, and if it's a pretty factoring problem, might be pretty easy. But many times I'm going to get irrational numbers. I'm getting like 5 plus the square root of 7 and that kind of stuff. And so in those situations, I'm not going to. It's more work to average than it is just to do negative b divided by 2a. Then once I have the x coordinate of the vertex, I'm going to plug it into the original equation, and get the y coordinate of the vertex. I'm going to use parentheses when I substitute in, right? Okay, now, if my parabola will have two solutions, my quadratic equation will have two solutions, I'm going to find them using the quadratic formula, factoring, or completing the square, depending on what the directions say. If there's only one solution or no solution, I'm not going to use the quadratic formula. It would be silly. I already know my solution. It's the vertex. If there's no solution, it would be silly to use the quadratic formula because I'm going to get an imaginary number. I'm going to get a negative under the square root. So if there are no solutions, I'm going to go right to a t-table. So if there's one solution or no solution, I'm going to go right to a t-table. Then, of course, I'm going to plot the 3 points. And I'm going to use symmetry. My third point is going to be super easy to find. Just a couple of checks about A. Remember, if A is greater than 0, if A is positive, your parabola opens upward. If A is less than 0, your parabola will open downward. Okay, solutions. If you get two solutions, your parabola needs to cross the x-axis twice. One solution means it'll cross the x-axis once, which means your vertex is sitting on the x-axis. So in this case right here, one solution, you know the vertex. It's the vertex. Did I mention that the one solution is the vertex? Then to find the other 2 points, Ashton, you go and use a t-table. All right. Now, if there are no solutions, I know that my parabola cannot cross the x-axis. Now I'm going to be referring to these steps. I'm going to go back here and do this problem. Hold on, something is opening up for me. Let me get rid of that. So let me go back a page here. And I am told to solve and graph by factoring. Now I'm looking at this, and remember, step 1 was to use the discriminant. But I know I'm supposed to factor this. And this is a really easy problem to factor. So I'm not going to use the discriminant on this. I'm going to go ahead and factor it. I see that's a trinomial. I see that I've got a perfect square here. And I've got a perfect square here. And if I do 3x times 4, I get 12. And if I double 12, I get 24. So this is going to factor just like this. 3x and then 3x and 4, right? Now there's a plus in the back. That's my Wendy's double stack. Bam. It factors. I know there's one solution. How do I know? Because I've got one quantity. Somebody will say, well, we got two quantities. Yeah, but the quantities are identical. So all I'm going to do is take 3x minus 4, set it equal to 0, solve for x. Sorry about that. All right, x is 4/3. That is the x coordinate of my vertex. Okay, that is the x coordinate of my vertex. So I'm going to make a little t-table here, and I'm going to put 4/3 in, or if you prefer, 1 1/3. Okay, now I'm going to go get the y coordinate of my vertex. And so I'm going to go y equals 9 times 4/3 squared minus 24 times 4/3 plus 16. It's nothing wrong with going a calculator here, especially since you're restricted on time. I'm going to go ahead and do it in my head, though. This is going to be 16 ninths. The ninths are going to cancel, so the first part's going to be 16. This is going to be minus 32, and this is going to be 16. Now, I'm actually being a little bit silly here. Can anybody tell me why I'm being silly? You see, 1 1/3 is going to be right about there. If I factored this and knew there was going to be one solution, doesn't my one solution have to be sitting on the x-axis? I didn't need to do all this work to get the y coordinate. I did it because I didn't think to, and it's good modeling for you on other problems. But think about what you're doing. If my x coordinate is on the x-axis, then my y coordinate has to be 0. Shouldn't surprise you. All right, now I'm going to put two other values in, and I think I'm going to put 0 in for x. And when I do that, I'm going to get 16 out. Well, I know it's going to go off the graph, so I'm just going to put it up here, and I'm going to label it as 0, 16. All right, now I went 1 1/3 to the left. Well, I'm going to go 1 1/3 to the right, which is going to be 2 2/3, and I have to get 16. So I'm going to go to about here, and there it is. And that's going to be the point 2 2/3 and 16. And then I can draw my parabola, hopefully. It's not going to look very U-ish, but you'll get the idea. It's a lot easier to do on paper than it is with the airliner, well, something like that. Okay, so there is how you solve one by graphing. Okay, now we're going to solve and graph by completing the square. Okay, now I can check the discriminant here if I want to, but I know when I complete the square, it's going to tell me how many solutions I have. All right, so I'm probably not going to do the discriminant again, but if you want, I can go ahead and do it. All right, so I'm going to go A, B, and C, and A is going to be 1, and B is going to be -6, and C is going to be 4. All right, so B squared, -6 squared, minus 4 times 1 times 4 again. Looks like I'm going to get a 36 minus 16, which is going to equal 20. I'm going to get two solutions on this one. I'm going to get two solutions. So now I'm going to complete the square. X squared minus 6x plus 4, set it equal to 0. X squared minus 6x subtract 4 from both sides. I'm going to take half of 6 and square it, so I'm going to get 9. 9. I'm going to factor x minus 3 quantity squared equals 5. Take the square root of each side. Going to add 3 to each side. All right, so now I've got two solutions, 3 plus the square root of 5 and 3 minus the square root of 5. At this point, I'm going to go to my calculator and get a decimal approximation because square root of 5 is an irrational number, right? So 3 plus the square root of 5 is going to be about 5 1/4. It's 5.236 So 1, 2, 3, 4, 5 and a quarter is going to be right about there. Okay, now I'm going to do 3 minus the square root of 5. And that's going to give me a little bit more than 3/4. So it's going to be right about there. Now, I'm not going to try to average these irrational numbers. They get confusing. So I'm going to use negative b over 2a. So the x-coordinate is 3. All right, so my vertex is along the line x equals 3. All right, so now I'm going to plug in 3, and I'm going to get 9 minus 18 plus 4, and I'm just kind of skipping a step. That'll be negative 9 plus 4. We're going to negative 5. Okay, so 3, 1, 2, 3, 1, 2, 3, 4, 5. All right, now I'm ready to draw my parabola. Yeah, let's see here. Oh, I don't like that last part. Okay, and if I work smart, not hard here, that should hit pretty good, and then I can just finish off the last bit like so. All right, and your parabolas will look better on paper. And remember, it's a U down here. It's a nice round shape, not a V. I think I made it look worse. Sorry about that. Okay, now we're going to do one using quadratic formula. I'm going to first go for my discriminants. I'm going to go A, B, C. So we got 1, 1, and 10. All right, b squared is 1 minus 4 times 1 times 10. That's going to be a negative number, isn't it? Yeah, so there are no solutions. So I am not going to go to the quadratic formula any longer. I don't need to use the whole thing. I'm going to use the x equals negative b over 2a. So my x-coordinate of my vertex is at negative 1/2. Now, it's not like the other one where it's sitting right on the x-axis. I'm actually going to have to plug it in. So I'm going to do negative 1/2 squared minus 1/2 plus 10. And that's going to be 1/4 minus a half, which will simplify to negative 1/4 plus 10, which will simplify to 9 and 3/4. So at negative 1/2, I'm all the way up here. Okay. Now to work smart, not hard, I'm going to plug 0 in, and I'm going to plug negative 1 in. If I put 0 in, I get 10. If I put negative 1 in, because of symmetry, I will get 10. All right. And then my parabola will do something like that. Okay. And I think tomorrow night I'm going to post a video where I do 1 or 2 negatives, just maybe like 2 problems. Okay. This one here, I have to graph this parabolic inequality. Now I know because it's not equal to, I'm going to get a broken curve. It's going to do something like this, or perhaps like this. Some of you can tell me it's going to be the latter because A is not negative. Excuse me. All right, and I know that there's going to be shading involved. Maybe I'll shade inside, or maybe I'll shade outside. I'm not sure. All right, so first of all, I'm going to go A, B, C. A is 1, B is 0, C is negative 4. I'm going to find out how many solutions I have. By the way, some of you are thinking, hey, that'd be an easy one to graph. Factor, yeah, it would. But I'm going to go ahead and do the quadratic formula since I haven't done much with it. All right, so b squared is going to be 0 minus 4 times 1 times negative 4 is going to be 16. So there's going to be 2 solutions. So now I'm going to find the x-coordinate of my vertex. Hold on, 2 solutions. X-coordinate of my vertex is going to be 0. Yeah, 0, definitely. So in my t-table, if I put 0 in for x, I'm going to get negative 4 out for y. I'm doing that kind of quick, but you should be able to follow that. All right. I've got my vertex. Now I'm going to use the quadratic formula to find my 2 solutions. Negative b plus or minus the square root of 16 divided by 2a. Well, that's going to be plus or minus 4 divided by 2. Well, that's going to be 2 or negative 2. It's 2 and negative 2 technically. Okay. And then my parabola will do something like that. And I'll flip the part over, and it should match pretty darn good. Okay, there you go. All right, let's do a couple application problems. Now remember, with application problems, the whole key to them is this equation. Oops. H equals negative 16t squared plus or minus v sub o t plus s. And that's for the one in feet per second. If they give you meters per second, the only thing that changes is the 16 is a negative 4.9. All right. So a baseball is thrown upward with an initial velocity of 64 feet per second. If it is thrown from a height of 4 feet off the ground, determine when the ball will hit the ground. So I'm going to work on part A first. Okay, and so my equation is going to look like this, negative 16t squared plus 64t, and the initial starting height is 4. When will it hit the ground? Well, I'm going to make h equal to 0. And I can use the quadratic formula. I can um, factor, complete the square, lots of other things on this. Sorry, give myself more room to work. Okay, I'll tell you what, I'll go to the quadratic formula on it. And so A equals negative 16, B equals 64, and C equals 4. So I'm not actually going to find the discriminant. I'm going to use the whole formula because I need to know when it's going to hit the ground. So I am going to just go right to the formula. So T is going to equal the negative B plus or minus square root of B squared minus 4 times AC, and the whole thing is going to be over to A. And I was going to simplify that, 64 plus or minus, and I don't know 64 squared off the top of my head, 4096, that seems really familiar, I don't know why, plus, and I think that's going to be 256, yeah, alright, 256, that's over negative 32, something strange just happened there, for some reason I reverted to a different pen, but that's okay. Alright, so I've got negative 64 plus or minus, and I've got plus 4096, 4352. That'll be divided by negative 32, and the negative 64 plus or minus, take the square root of that 4,352, and I'll get approximately 65.9696901 divided by negative 32. And so let's see here. So for one of them, one of my times, I'm going to get 4.06 seconds. So about 4.06 seconds. For the other time, I believe it's going to be a negative, and so I'm not even going to go to find it. Okay, I will get a negative, but I happen to get the positive one first. So that's the question A. Answer A is be 4.06 seconds is when it'll come back to the ground. Now, when will the ball reach 50 feet? Well, in that kind of situation, I take the same formula, H equals negative 16t squared plus 64t. What was our starting height? Was it 4 feet? Yeah, 4 feet. Okay, but this time I don't put 0 in, I put 50 in. And then I subtract the 50 And I will get 0 equals negative 16t squared plus 64t minus 46. Okay, and I can go to the quadratic formula on that. Um, Now I'm expecting 2 times unless 50 is the vertex. So hold on a second. I'm actually going to go through everything. Hold on. Okay, did a little work so I didn't kill time on the video. There's negative b. There's b squared. And this is for a c, and it ends up being negative this time. And so now I can simplify further, and I'm going to negative 64 plus or minus the square root of, that'll be 1,152 divided by negative 32. And then will be negative 64 plus or minus 33.9411255 divided by negative 32. Now, of course, I'm not typing all those numbers in my calculator. I'm letting the calculator use them. So let's see here. One of the times will end up being 3.06 seconds. And then the other time it reaches 50 feet will be, let's see here. Hold on. It'll be about 9.4 seconds. Excuse me, 0.94 seconds. Okay. So obviously this one here is on the way up and this one's on the way down. The ball is going to do something like that. And so it's going to fit 50 feet here and it's going to fit 50 feet here. All right, one more example. If football is kicked off the ground with initial velocity. Now, Mr. Wolf, you keep asking, do I have to draw the picture? I think the picture helps build the understanding. So here's my football. I know it's kicked off the ground, doing something like that. Whoa, hit a little snag there. Wait, where's my eraser? There it is. All right. Yeah, it looks a little bit better. Initial velocity of 25 feet per second. Will it be able to go over a goalpost? So I need my goalpost in here. 9 feet off the ground. Okay, 9 feet. Okay. So again, h equals negative 16 t squared plus 25 this time t. The ground is 0. Now the height is 9 feet. I don't need to plug anything in. This is asking me what the max height of the parabola is or what the vertex is. If I just go find the vertex, I'll be able to answer the first question. So I'm going to go ahead and go t equals negative of b over 2a. I don't believe that'll simplify other than to become positive. And so then I will see how high it goes at 25-30 seconds of a second. So I'm going to get negative 16 times 25-30 seconds squared plus 25 times 25-30 seconds. All right, so negative 16 times 25 divided by 32 plus 25 times 25 divided by 32. And I get that the height is going to be about 9.77 feet. So yes, it will go high enough. Okay. Now, at what time will it reach 9 feet off the ground? Well, here I'm going to have to go ahead and plug 9 in for my ending height and then solve for t. So I'm going to go 9 equals negative 16 t squared plus 25 t. And I will subtract 9 from both sides. So I'm going to get 0 equals negative 16 t squared plus 25 t minus 9. And then I'm going to go to the quadratic formula. And so I'm going to get negative 25 plus or minus the square root. 25 squared is 625 minus 4ac. So let's see here. Minus 4a and c. So it's going to be 36 times 16, which is 576. That's over negative 32. So I end up with negative 25 plus or minus the square root of 625 minus 576. 625 minus 576. 49. Ooh, that's nice. I like that. Negative 32. So I get negative 25 plus or minus 7 over negative 32. So now I will have negative 32 over negative 32, which equals 1. So 1 second. And I will have negative 18 over negative 32, which I can simplify by 2, which will give me 9/16. And 9 divided by 16 is, okay, about 0.5625 seconds. Of course, you could give this as an answer. That would be acceptable. Nothing wrong with that. So it's going to go at 1 second. Here, this is going to be 1 second. That'll be 9 feet. And the other one will be at 9/16 of a second. And there you go. All right, I tried to keep it short, but like I said, tomorrow we'll post a video, 1 or 2, where you have to go through the whole quadratic formula for the purposes of graphing. All right, Mr. Lawrence signing off. Good night, everybody.